So we are going to go ahead and introduce ourselves. So you're in the Biomedical Engineering webinar for the VT Open House. I am Dr. Sarah Rita. I am the Interim Undergraduate Program Chair for our Biomedical Engineering undergraduate program.
Hi, my name is Amanda Sandridge, and I am the Undergraduate Academic Advisor for Biomedical Engineering.
And we have a couple of students with us here today, current BME students. So go ahead, Jessie.
Hi, my name is Jessie, and I'm a junior in Biomedical Engineering.
And Michelle.
Hi, I'm Michelle, also a junior in Biomedical Engineering, and I participate in some on-campus research. If anyone has any questions about that, I'll be happy to answer.
And Julia.
Hi, I'm Julia. I'm also a junior in BME. I'm also doing a minor in visual arts. So if you guys have any questions about doing a minor, something that's just not really conventional with engineering, go ahead and ask me. I'll be more than happy to answer.
All right, awesome. So how our webinar is going to work is we're going to show a quick, I think it's a 4-minute video.
I think that the advantage of having a biomedical engineering undergraduate degree is that it is, number one, distinct from other engineering majors. It addresses a societal need for having students that have strong engineering fundamentals that are necessary for the field, but then an ability to understand how those principles apply in mechanical settings, electrical settings, chemical settings that might be part of a biomedical problem. And so their experiences are applicable to a variety of problems that industry would be interested in. I think what they can expect is very dedicated faculty, hands-on experiences, a range of problems that they might encounter later in life in their jobs they're going to be exposed to here. We have a new curriculum which has permitted us to look at other curricula around the country, take advantage of what we have specialized here at Virginia Tech, but then also where we see might be not as prevalent in other programs across the country.
There's a lot of unique elements in our curriculum in order to really develop leaders in biomedical engineering. A lot of the elements and skill sets are developed during the curriculum by looking at the FDA and looking at medical devices themselves and breaking them down and understanding the design of them and how to build new innovative approaches. Students who are interested in pursuing a career path in any type of healthcare industry, whether it's manufacturing, whether it's designing, all these types of processes they'll be exposed to during their time here at Virginia Tech.
In our biomedical class, on the second day, they set us down with a medical device and said, take it apart and tell me what it does. And that was exciting because you've been told, hey, don't take that apart, or hey, put that back together, please. But for one 10-minute major that allows me to take things apart and not get in trouble for it, and I've absolutely enjoyed that.
I'm really excited to watch the program grow with the new medical school here at Virginia Tech, as well as the initiatives in a global community and global learning. These aspects we can build into our curriculum and really give unique opportunities to students that they can't get anywhere else.
So our lab primarily studies focused ultrasound technologies for medical and now conservation applications. So we're developing focused ultrasound transducers and other devices as tools to really generate high amplitude sound waves at a single location in the body. So these are to develop completely non-invasive therapies for cancer and other applications.
We're trying to create a machine learning algorithm that takes in ultrasound images of tendons. So if you look at these images, this is a normal tendon, and then this one's an injured tendon. And as you can see, they have physical differences. And those are things that physicians look for to determine whether they think a tendon is going to be injured or not.
So we're focused on understanding both injury prevention and then recovery, mostly in the orthopedics realm, trying to understand both our young athletes as well as our older adults and how we can get them back to doing the things that they love to do. We're working on direct engagement with our clinicians and our clinical faculty to try and translate the work that we do here in the lab out into the clinic setting.
So part of my fellowship is I go to a NASA center every summer for about 10 weeks. So the past 2 summers, I've spent time at NASA Johnson Space Center in Houston, Texas. NASA is planning to send the first woman, next man to the moon in 2024. And the hope is that my research can help understand and help design for human health and performance on these future surface exploration missions.
And I also do want to add that almost all the actually all the clips that were presented here were filmed in December 2019, January 2020, and February 2020, so before the COVID pandemic. So with that, we'll go ahead and open up to questions through the Q&A. So our first question is, what is the percentage of females in the VT BME program? So I think Ms. Sandridge might have the best idea on the exact numbers.
I don't actually know the exact numbers, but we're actually about 50-50 right now with our junior class. We're 50-50 split with BME students that are male and female. Our sophomore class is a little bit more 60% female, 40% male. And we're still working on, we're currently recruiting for our next class, so we don't have numbers on that one yet.
And one of the other questions that we had are, what are the career options with a BME degree? Well, BME degrees can be used in a wide variety of fields. So even though we have our first cohort will be graduating next spring, of which actually all 3 students that are here right now are graduating next spring. We don't have any data on our particular students yet since none have graduated, but kind of historically with BME programs, typically students are going on to about a third, I say, go on to industries such as biomedical device companies, a third go into graduate school, and then the other third are either going into government labs and or clinical school, like a medical school or PT.
Mm-hmm. I know the oddball out in our biomedical cohort, but I'm actually studying right now and plan on going into medical law, so I'm studying for my LSAT right now. But yeah, so you can use it for a wide range of degrees. So I'm looking at patent law and medical law, and you have to come from a STEM background for that. So there's another way you can use your biomed degree.
So I see somebody asked the question as, what classes do you take in this program? You can see the check sheet for the degree on our website. If you go to our website and look under the undergraduate degree program, you can see the checklist for the degree. And somebody else asked whether it leaned more towards mechanical or whether it was more towards cell, or what courses that you took, like chemical. So basically our degree is very heavily a mechanics-based degree program. It's not a pre-med track program, but there are 12 credits of BMES technical electives and 9 credits of technical electives that students can choose that allow students to tailor the degree towards what they would like to do, based upon a set of courses that are already listed on the check sheet that they can choose from. So it is very heavily mechanics based, but there are courses that they can choose from to tailor the degree towards what they want to do. So it can be biomechanics related, it can be cell related. It's really dependent upon what they're interested in as to what the coursework they choose to do.
See, and another question, I'll throw this to our students that are here, is what are some of the high school classes or extracurriculars that you took, and what led you to an interest in BME?
Okay, I guess I'll answer this one. I came from a really small private school, so I didn't really have access to a lot of high school classes that would give me that opportunity to see much of engineering. I did take part in this NASA dual enroll program when I was in high school, so I got to take part in I was taking classes through NASA while I was in high school, and then I got to work at NASA one summer, so that kind of piqued my interest. But a personal reason for me is that I had 5 surgeries growing up that I was going to be paralyzed if a biomed engineer hadn't come in and, like, stepped in and, like, saved my whole arm. So that's my reason for doing it, and my mom was a biomed engineer, so I kind of got to watch it my entire life and see what biomed engineers really do in their day-to-day lives, and that was just something that really piqued my interest.
I also went to like a private school, and they didn't really offer a lot in terms of like AP classes, but however, I was always drawn to more of like the biology side of like science, and I was also really into like art. Like I took AP art in high school, and so what really drew me to this major was that the fact that like I love the arts and I love science and like biology, and this major was just like the perfect kind of like in between where I can just mix together my two passions and use it for like making things that will help people and change people's lives. So that's kind of like my little personal reasons for going to biomed. But I would say that like if you have just like the slightest interest in biomedical engineering, like please do your research. It will surprise you how like how like a wide range of applications like this major can be used for. And I feel like although it can be seen as like something that's very niche, it's also such a great gateway into so many other career paths. So again, like I highly recommend, like, I mean, obviously you guys are interested if you're here, but I highly consider taking biomedical engineering more as like into the front of your mind, and I really think like you would fall in love with it.
Like, I guess for me, what I wanted to do biomedical engineering. I was originally very interested in like being a doctor and going to medical school, but then I decided I didn't want to spend like an extra 4 years in med school and residency, and also I liked more of the design aspect of biomedical and like medicine, and so I kind of wanted to be like the person making the technologies used in hospitals as opposed to being like a physician. Um, and I'm definitely like more like math and science heavy, so that's kind of was more up my alley. So that's what got me interested. In terms of like what you should do in high school to like help pursue that, I would say take like all your highest math classes you can, like calculus, even statistics, which I didn't realize because in my high school they were like, oh, engineers don't need statistics, but you use it a lot. So if you have a stat class to take in high school, it's very good to have like that basic background. And if you have any kind of like design teams or like pre-med clubs at your high school, I'd recommend doing that, just kind of exposing yourself to like problem solving and different like needs in the healthcare industry that you might become interested in.
So there's a couple of questions about research opportunities for BME students at Virginia Tech. I think, Amanda, did you want to answer that one? Or would you?
So we do have a lot of research opportunities for students within our department. One thing that we're able to do right now for our students, I don't know if we're going to be able to continue it in the future as our department grows, but right now what we're able to do is the first 60 hours that our students do research within the department, we're able to pay them. And after that, it's expected that the students will be able to the professor that they're working with will be able to pay them for the research that they do within that lab. Students can also earn credit for undergraduate research, but you can't earn credit and also be paid. So it's either be paid or earn credit, but not both at the same time. So that's something that's very popular with students within the department. I think Michelle's done undergraduate research several semesters while she's been here. I know she's done it over the summer as well, but that's something that's very popular. Our undergraduate minor has a research component as part of the credit hours. 6 of the credits must be research focused. So we are very heavily focused on research within the department.
Let's see, another question that we had come in was, what aspects of biomedical engineering does our program here at Virginia Tech focus on? And how can you customize your courses to be that specific to that interest? So as faculty and kind of research areas that we have available and expertise, the 3 main areas that our program focuses on is biomechanics, which can range even from cellular biomechanics, forces and flows at the cellular level, all the way up to biomechanics of human movement. So how and why we move and injury prevention, rehabilitation. Another area is biomedical device development. And then the third one is cell and tissue engineering. So the great thing about our program is that we have 21 technical elective credits built into the curriculum. And the reason we did that was specifically so you could tailor your BME degree to what you're specifically interested in. BME is a very wide range, as you can probably tell. You can go and look at cells and kind of on the genetic level, or you can be looking at a whole body or looking at a device interacting with the body. So with that, you need to be able to tailor your curriculum to what you are particularly interested in. The 21 technical elective credits can let you do that. So for example, if you're interested in medical device development, you can take some more, we have some biomedical device classes, bioinstrumentation, some signal processing, and other courses like that. Another question is, what kind of extern interim programs are available for biomed engineering? I'll start a little bit with this and I'll let Amanda give a little bit more details on it. So right now we have a couple of staff dedicated specifically to partnerships with industry. So Dr. Vincent Long is the one that is leading our industry partners. And we also have a director of experiential learning, Dr. Chris Arena, and their focus is on building those partnerships with industry and kind of building the network for students to be able to do co-ops, which would be during a semester, say taking a spring semester off, working with a company and coming back, or summer internships. As well as different experiential learning, for example, shadowing within the Carilion Medical Center up at Roanoke, or also at Lewis Gale, which is the local hospital in Blacksburg.
So typically, if a student chooses to do a co-op, the way our semester offerings are for coursework are currently done, if a student chooses to do a co-op, it usually spans over 2 semesters just instead of just 1. If it is just 1 semester, a student would typically need to pick up a minor in order to add to the degree because it's almost difficult to do just 1 semester of a co-op and return and pick up the coursework without missing things in the sequencing. So typically a co-op is a 2-semester sequence. The other great thing about Virginia Tech is we have Engineering Expo every fall where companies actually come in and there's a wide variety of internships, co-op experiences and jobs that students can apply for during that Engineering Expo. It's one of the largest career fairs for engineering on the East Coast.
And I would like to say a little bit on the co-op. Like there are co-op opportunities. Like I personally am going to work at Merck next year in Elkton, Virginia, which is right by Harrisonburg, and I'm taking a year off to do like a year-long co-op, and that's a pharmaceutical company which is going to be making COVID vaccines very excitingly over the next year. But yeah, for biomedical engineering, like what I found is most of my opportunities are usually like research focused, so a lot of like undergraduate research fellowships. But there are definitely some companies like pharmaceuticals or medical device companies that are looking for more like interns or co-ops.
Let's see. So another question that came through was, are there any opportunities for study abroad and where would those opportunities be located? So one of the opportunities that is currently available, though not obviously this summer, unfortunately, is there's a study abroad in Malawi looking at medical resources and improving medical resources and engineering for engineering medical devices specific pediatric. There are opportunities for study abroad. For example, one of our faculty, Dr. Jared Gregg, has organized a study abroad in Europe that is also gets you course credit for deforms and dynamics. That's an opportunity over the summer to go there, and you also can complete some of your coursework through that.
Someone asked what's the difference between a major and a minor in BME. A major in BME is 124 credit hours. 21 of those credit hours are BME specific content or technical electives, as well as additional coursework that's very specific to BME. Whereas if you do a BME minor, it is only 18 credits of required coursework. So it's very different. 124 hours versus 18 credit hours. It is possible to do a double major in something like English and BME. It takes a lot of planning to do it, but it is possible to do it, especially if you bring in dual enrollment or AP credit, and if you're willing to do like summer classes or possibly stay a little bit longer than the traditional 4 years.
Let's see. One of the questions is, would I be able to learn more about prosthetics in the you are able to. So prosthetics is kind of considered in what we consider in the biomedical device. So we actually also have a club that Julia is a part of called Enable, which is 3D printing of prosthetics to meet a local child's needs or upper limb prosthetic. There's also the coursework that you can go towards designing the prosthetics themselves, as well as we have working relationships with Virginia Prosthetics and Orthotics, where they've come and given guest lectures specifically about their experience and are willing to give tours of the facility. Obviously, right now with COVID, that hasn't been able to happen yet, but we're really looking forward to the time when we're able to kind of go in there and see how the technology is adapted and used in the clinic. As the VTBME program. So currently we are in our second year. So the students here are our first cohort going through. They entered as sophomores and they'll be graduating next spring. What is the application process to the BME program like? We are currently under a limited enrollment through, is it 2023, correct?
Yes.
After that point, the application process is like any other major at Virginia Tech. So you have a common first year in engineering education.
Any other major in the College of Engineering.
Sorry, any other, I apologize, thank you. Any other College of Engineering major is you have a common first year in general engineering, and at the end of your freshman year is where you do the change of major process into your selected major based upon GPA.
A 3.0 guarantees your first choice major, and after that, it depends upon if there's availability within the program. So a question is, do any of your research efforts overlap with chemical engineering like drug delivery? We don't specifically overlap with chemical engineering, but our students are welcome to do undergrad research in chemical engineering with a chemical engineering faculty member if they wanted to. We do have professors that do some research in some chemical engineering type type areas. So if the students chose to, they could do research with those professors as well. So there's lots of overlap in curriculums and lots of interdisciplinary research going on within our department and many other departments. So yes, by all means, there's lots of research going on in drug delivery and within chemical engineering.
You also have the chance to take courses for your electives that overlap with or that are in other departments. So you can take you could take electives that are in chemical engineering if you so chose to.
And I guess I'll also add there is a lot of faculty that we currently have that are looking at different targeted drug delivery mechanisms. And as Ms. Sanders said, work on interdisciplinary teams. So there are, for example, maybe some chemical engineers involved in the research as well. But as an example, Dr. Rafael Davalos looks at using electric fields to be able to enhance drug delivery, particularly in the brain, to bypass for getting around the blood-brain barrier, as well as Dr. Young-Woo Lee looks at facilitating drug delivery using nanoparticles.
And as part of our cellular engineering class that you'll probably take your junior year, we had to do a project on some kind of like nanotechnology in like cellular engineering, and one of the major topics of that was like drug delivery using nanoparticles to deliver drugs in like biological systems. So they definitely there's definitely multiple instances where you can be exposed to that throughout the curriculum.
Does anyone else have any other questions right now? If we don't have other questions, I'll have Michelle talk a little bit about the undergrad research that she's doing. I'll put her on the spot. Michelle, if you don't mind, would you go ahead and talk a little bit about undergrad research?
Yeah, I'll start, and if any questions pop up, I'll stop. But so yeah, I've been in a couple different undergraduate research labs. So I'm currently a junior. So kind of going back to the question about chemical engineering, there's a lot of cross-disciplinary like opportunities. So my freshman year, I was actually like in a computational neuroscience lab that was under the College of Neuroscience. And that's, we used like EEG signal processing. So like, you have your electroencephalogram cap, and we got to see signals from people when they were like asleep and what different stages of like the sleep cycle they were in. And now I'm currently in Dr. Vandervoort's lab, which is under the College of Engineering. And that's related to blast injury. So I'm still kind of in the neuroscience field, but now it has a more biomedical component to it. So we look at the how brain tissues, like the chemical composition of brain tissues, are affected after a blast injury. And this is supposed to help us understand, like with soldiers when they're out in the like field, and if they have like been exposed to like a bomb detonation, like how we are able to look at neural degradation in their brains and be able to like have earlier diagnosis so we can better treat these patients. So currently I'm doing tissue staining to look for certain areas of the brain that have been exposed to blast injury and see how if there's been any chemical changes resulting from the blast injury. So it's been definitely a lot of fun. There's a lot of research opportunities in the BEAM department, and with it being a small department, you get to know the faculty fairly well, and you get to be pretty aware of the research opportunities. So if you are interested in anything, most of the faculty are very excited to tell you about their research, and are excited to like have you volunteer or even be like a paid researcher throughout your time at Virginia Tech.
And I'll also put Julia a little bit on the spot to talk about some of the clubs she's involved in, as well as her interdisciplinary design project.
Yeah, cool. So I've been a part of this club at Virginia Tech called Enable. And what we do is that we design and we 3D print prosthetics for those around the New River Valley area. And it's just really fun to work with. And it's like, it's not limited to like any majors or anything. So you get like a whole wide range of people, mostly engineers, of course, but it's really interesting to come together with like different people in different disciplines to make these like design these like 3D prosthetics. And I've gotten a lot of more experience with like 3D CADing, like softwares and stuff like that, and just like more hands-on like mechanical engineering and just like medical devices as well. I'm also a part of the a senior design group, and we are making a hip exoskeleton device for our end user who suffers from right hip osteoarthritis. And so we're trying to design this device to help him with his movement, and also to be like a pain reliever, kind of like therapeutic device. So it's really cool to see like biomedical engineering being used in like these different wide like ranges of things. So, and there's a lot of opportunities within this major. So I definitely recommend biomedical engineering to anyone.
So thank you for joining us.
Thank you.